Let's take a look at another quadratic here that has w's on both sides of the equation here. You've got a big, huge, equation on the right, and we need to simplify this. W plus 6 squared is going to give me w squared plus 12w plus 36. That's a perfect square. When I do all that, that's what I'm going to get. On the right side, looking at this one here, I'm going to get 3w plus 36, okay, minus w squared. All right, let's simplify terms. Look at like terms. The squares first. Okay, when I bring w squared over, it's going to give me 2w squared. Be careful, it's a plus over here, it's a minus over here. When I add w squared to both sides, I'm adding it over here, so 1 plus 1 is 2. Or if I bring this one over, remember when it comes over, it's got to become from a negative to a positive. Okay, now I have a 12w here. If I bring 3w over, 12w minus 3w gives me a plus 9w, right? If I subtract 3w from each side, minus 3w, there's my 12 minus 3 is my 9. 3w minus 3w, that goes away like I want it to. Okay, same thing with 36. If I subtract 36 from both sides, those go away. Subtract 36 from this side, those go away. And all I'm left with is 2w squared plus 9w. That's it. I move this w squared over, right? I move the 3w over, and the 36 is one away. I got nothing on the right. Okay, so here's my new equation, and factoring becomes very easy. I hope this doesn't freak people out, but take a w out. You got w squared and a w, take the w out. I would take a number out as well if I could, but I can't, right? 2 and 9, they don't have a common factor. So I'm going to take the w out. I'm going to be left with 2w, right? W times 2w would give me 2w squared. And if I pull the w out of 9w, I will be left with a 9. Okay, now here you got to be careful because this is simple, but I see a lot of students have trouble with this. Okay, if either this or w is equal to 0, 0 times anything, right, whatever's in the parentheses, makes this a true statement because 0 times anything is 0, and 0 equals 0. So I don't care what's in these parentheses right now. If w is 0, that is a solution. So that's one part of my solution. W is 0, because if that's 0, the whole thing's 0. The whole left side is 0. Now, in similar fashion, if whatever's in these parentheses equals 0, I don't really care what w is, because if these parentheses come out to be 0, 0 times w, 0 times anything is 0. So two solutions. If this equals 0, or if this equals 0, give me my two solutions. So what's in the parentheses? 2w plus 9 equals 0. So I just set the parentheses equal to 0. I ignore the w, and now I'm going to find this, okay? 2w equals, or I'm going to solve this. 2w equals minus 9, divide by 2, and I get minus 9 halves. There are my two solutions. If w equals minus 9 halves, the whole thing works. If w equals 0, the whole thing works. So the book might show your two solutions as minus 9 halves and 0. Again, I don't necessarily like this because it looks like an ordered pair. It's not an ordered pair. But when w equals minus 9 halves, that's a solution of the equation, and when w equals 0. Hey, 0 is easy to check. Let's try it. Okay, 0 plus 6, 6 squared to give me 36. W plus 12, that's 0 plus 12 will give me 12. 3 times 12 is 36. Oh, w squared, I said if w is 0, oops, that's a minus. If w squared, if w is 0, then that's 0. So this all goes away. Is 36 equal 36? Yes, that means it works. I would get the same thing if I plugged in my other solution of minus 9 halves, but I don't care to check it. But I'm showing you that if you plug in the 0, it works. If you plugged in the minus 9 halves, it'd be a little bit more math work to do, but it also will work. It has to.